Hello, my name is Samuel Schlafer, and this is my Physics 2211 Lab 3 Black Hole Simulation presentation. Introduction to the lab. For part 1 of the lab, our purpose was to use GlowScript code to create a simulation to find the mass of a black hole by analyzing a star's orbit around it. Then for part 2, our purpose was to find the initial velocity a spaceship must have to leave the surface of a moon and fly around a planet in a figure-8 orbit without crashing into either the planet or the moon. Some of the fundamental principles behind this lab are universal gravitation, Newton's second law, parallel net forces, and perpendicular net forces. This is my GlowScript code that I used to find the mass of the black hole. I dictated what initial velocity, initial momentum, and final momentum were, then used those to calculate the net force on the star, and then the parallel and perpendicular net forces. So these are my results, and I got that the mass of the black hole was 1.93351 times 10 to the 34th kilograms. For part 2 of the lab, we had to find the initial velocity of a spaceship needed to leave a moon and then create a figure-8 orbit without crashing into a planet or a moon. So this is the GlowScript code I used to do that. On the left is the givens that I used, and on the right is the different position vectors and then the forces I found, including the net force on the moon and then the net force on the ship from the all 4 objects in the surroundings. For this part of the code, the system was the ship and the surroundings would be the moon, the planet, and the star. For the results for part 2, I got that the velocity of the ship and the moon were both negative 50 meters per second. Were the code to run longer, it should make a symmetrical figure-8. This is a still image of the results of the code. The cyan orb is the moon, the pink orb is the ship, and the blue orb is the planet that they are orbiting. Some possible errors for this lab. There's a lot of approximations, so not everything is accurate just simply because it's a simulation, and there's a lot of assumptions based off of this simulation. And then just accuracy. I use a lot of trial and error to find the velocities in order to try and get a symmetrical figure-8 orbit, so it didn't work out quite perfectly. And the code that we were provided for the second part didn't run long enough for the figure-8 to form, only for it to begin to form. So it could be more precise when you come to the part 2 of the lab, but with what we were given, these were the answers that I got. So some questions. How is the net force and its parallel and perpendicular components different from the rate of change of momentum? So mathematically they're the same. However, momentum change rate is much easier to calculate. We need to know every external factor acting on the system for the net force and its components. However, for just the rate of change of momentum, you only need the change in the velocity of the system. So second question, this imaginary system has a black hole, a star, a planet, and a moon. If I wanted to predict the motion of the entire system, what would I need to include in my computational model? So if we were thinking about the motion of the entire system, I would need to consider all of the parts of the surroundings that are acting on the system in any way, and vice versa. So it'd be pretty much the same thing we did in part 1 of the lab, just on a larger scale with more objects. And there will likely be dominant forces between all 4 objects in this system. So in order to figure out the general motion, you would just need to do pretty much part 1 of the lab over again for all 3 of the new objects and then consider them as a whole.